We left off and we have one more problem to do. Okay, so the problem that we have left to do, let's all pay attention. We have a test next time I see you. Yeah, we are doing the number 11. We're doing the last problem. Okay, and it says, we charge on a credit card with an interest rate of 18.99%. You decide to make monthly payments for 3 years. What are your monthly payments and what is the total amount this shopping spree will end up costing you? Okay. All right, so first thing you got to do is figure out what formula you're going to use. So you are going to make monthly payments. So that tells us it's either FV or PV, right? Which one?
FV.
Am I saving for the future when I'm paying off my debt? No. If I am paying off a debt, I have to use PV. So I'm going to use the PV formula, which will be given to you. So I got to get it here. I don't think I put it on the paper, so I got to get it out of my notes. So the PV formula looks like this. All right, so here we go. Let's put in what we know. We are looking for the monthly payments. So R is our unknown, which is sort of good news. It means we're not going to need logarithms, right? Because we only need logarithms when we're solving for a variable that's an exponent. I charge $1,234, so that's the present value of my loan. That's what I owe. That's the present value of what I owe. The interest rate is 0.1899, and if you've ever looked at a credit card statement, that's about right. I mean, they're pretty high, those credit card interest rates. But remember, when I put in the I in this formula, it has to be divided by the number of payments I'm making a year. These are monthly payments, so I'll divide by 12. And that goes in the bottom too. Now, what is my N in this formula? The total number of payments you're going to make over the life of the loan. Okay?
36.
36, because we're making monthly payments for 3 years. This is the formula that does have the negative though. It's right there in the formula, so you can't miss it. Now, solving for R is going to be easy. It looks like it's not going to be easy, but it is going to be easy. Because we just need to divide 1,234 by this bracket, don't we? Isn't that how we'll get R by itself? So we're going to figure out the value of that bracket. And then we're going to divide it over to the 1, 2, 3, 4. So here we go. Everybody on your own with your trusty calculator, doing it however it works for you. Anybody got a payment amount? are? Someone shout it out. Next time you have to do it on test.
$45.23.
Yep, $45.23, that's exactly right. Now, you're thinking to yourself, oh, that's not so bad. So let's see how much she will have paid, or this person would have paid total. So in other words, we're gonna pay $45.23 times 36, okay? So the total amount that we've paid is $1628.28. Right? And some of you are still thinking, oh, Ms. Ford, that's not so bad. But let's do a little percent of change on that. Remember how that works? Let's find out how much more what percentage more she actually paid. Remember, you take the difference, so we're going to take the difference in these two amounts, and then divide it by 1, 2, 3, 4, the original. This is a 32% increase. So she paid, by financing it on her credit card, she paid 32% more for the privilege of doing that, I guess. So, moral of the story, don't use your stupid credit card unless you have enough money to pay it off. Pay it off every month. I use a credit card, but I pay it off every month. This can really get you in trouble, and I promise you, when you get to college, and it may already started, but you're going to be bombarded with credit card applications. I mean, you're going to get them all the time. When you're going to go to orientation on a college campus, like they have those, with COVID and all that, there will be booths, tents set up where people will be signing you up for credit cards because inexperienced consumers fall prey to that, and then you end up having huge credit card debt. Don't use a credit card unless you can pay it off, or unless mom and dad are paying it off for you. All right. Yes. Whoops.
What did you, with 1,628.28, what did you subtract that by again?
Percent of change is the difference between the original and the new divided by the original.
Okay.
All right. Now we have been through basically everything on this practice test. So we have a choice now. We can just go to a different thing. I have, there's lots of different review sheets here. And just start cranking through another one. Or if there is one particular thing that you have a question about, we can focus in on that. So what we're not going to do is stand here. I can't stand it. I'm going to get started on something.
This section of the last one, but every time I plug it into my calculator, I just get weird answers.
Okay, that's probably, I'm not going to take class time to go through that, so tomorrow morning, come in for office hours and we'll straighten that out. Okay? Let's turn to for me, it's the last page if you're using my packet I gave you. It says final test practice. And it looks like there are some answers written there too. It looks like I tried to conserve some space so I have some answers written there. Anybody see anything on there we need to do? Final test practice?
Could we do number 6?
Yep. Find the interest rate, this is number 6 on final test practice. Find the interest rate compounded monthly necessary to triple an investment in 17 years. Okay, what formula are we using? This is number 6 on final test practice. Yep, I gotta use one of the ones I have memorized, and it's this one, right?
Yeah.
because it says in the problem compounded monthly. So compounded monthly means that's the formula, okay? Now, I want to triple my investment. Do they tell me what my investment is? No. All I know is I can start with whatever I want, I just have to end up with 3 times it. So you can start with 1 and end up with 3, you can start with 10 and end up with 30. It makes 0 difference. Start with something and end up with 3 times it, because you're tripling the investment. We are looking for the interest rate, but we know it is compounded monthly, and we know we're doing it in 17 years. So are we clear on where all those numbers came from? Now, the first thing, let's go ahead and do that little multiplication. So 12 times 17 is 204. And then I'm going to go ahead and divide by this, right? Always, always, always. So whatever, you should end up with a 3 here. And I think we looked at one of these the other day. Because, first of all, you are not going to use logarithms. Because your variable is not up here. This is the only time you use logarithms. What we are solving for is buried in this parentheses, and we need to get it out. Read.
I was just wondering, do we have to memorize all the formulas for the test?
Someone help him out. What have I said? You got to memorize the first 2, and then the others are given.
Okay, thank you.
All right, how do I get that R out of that parentheses?
Didn't you say yesterday you do like a loopy?
I do a what?
Like a loopy?
No, I don't loop-de-loo this guy. I only loop-de-loo when I'm getting rid of a logarithm, and I don't have a logarithm.
You take like the 204th root.
This is where I take the root of both sides, exactly. I need to get rid of that 204, so I'm going to take the 204th root of both sides. Now, myself, yesterday, or whatever day that was, we went through, and we've done it a couple of times, how you do the 204th root on your calculator. Personally, I just type in 3 to the 1 over 204th power. That's how I do it. You do not have to do it that way. You either take the 204th root, or you raise it to the 1 over 204th power. One or the other. Then, once you get that number on your calculator, which, by the way, should be about 1.0053, da-da-da. Once you get that number on your calculator, remember we're solving for R, so we'll subtract 1 and times by 12. So the interest rate is about 6.48%. I got 0.064798, da-da-da-da. So I made that 6.48%. All right, anybody see anything else on this paper? Any other problem?
We do 9.
9, suppose you borrowed for a new car, the interest rate is this, you'll make monthly payments for 5 years. How much is each payment? If you put $3,000 down, how much will you ultimately pay for the car in total? All right, this is a little bit confusing. If it's all the same problem, we have to decide, okay, so we borrowed 12.5. Okay, so that's how much we borrowed. So that's the amount of our loan. And I need the formula again. Which one would this be? I borrowed money and I'm paying off a loan. So this is PV. Yep, this is definitely a PV. So there's that, and then I have 1 minus 1 plus. This is I. And negative N. Okay, I'm just going to go ahead and fill those numbers in. What's my interest rate? 0.0895. And aren't these monthly payments again? Yep. So this is 0.0895. And now I just need to figure out what power I'm raising this to. This loan is for how many years? 5. So 5 times 12, 60. So my exponent's 60. I'm gonna make 60 payments. So this actually is exactly the same as the last one we did, right? We need to figure out what R is. So we're just gonna figure out what this big bracket is and then divide 1250 by it. So when I do that big bracket, Ellie, type in the numerator exactly the way I wrote it. It equals, and then divide by the denominator in parentheses, and that should work. So let's see what we come up with. So what were your monthly payments? Anybody got it?
$259.
Yep, $259.18. So $259.18, 60 months. So in terms of the payment amount, it's gonna be $15,550.80. That's gonna be my payment amount. If I make this much per payment for 60 payments. But I already initially paid $3,000 in my down payment. So the total this car is gonna cost me, or has cost me, is $18,000. Because I already paid $3,000 right from the beginning. Okay, who else? Anything else on this one? And then we can turn to another one if we need to. Okay, are we comfortable with number 10? It's a multiple part question. Are we comfortable with all the parts of that? That's a logistic function. How would we figure out how many ants are present initially? Now be careful that for number 10, the formula is given to you.
500.
Right. You put in 0. If you want to know how many ants are present initially, that means X or T is 0. Remember, the initial value is the y-intercept. So X is 0, 0 comma. So to find the number present initially, we're going to plug in 0. How would we find out how many are present after 4 days?
Plug in 4.
Plug in 4. How would we answer C? How would we, what would we do with C? $342 is going to go in for the number of ants. So your equation is going to look like this. Right? Are we comfortable solving that, or do we need to solve that? You're comfortable? Okay. What is the maximum number of ants that the colony can support? 500. Yeah, limit to growth, that's the maximum. It can withstand, or it can, okay. 2C. Where is the asymptote of that thing? Y equals 3 to the x plus 2. Where's the asymptote going to be? Y equals 2. Remember, gang, in an exponential, this is an exponential, the asymptote's on the axis. If you add 2 to it, it's going to take the whole picture up 2. So now your asymptote's going to be at y equals 2. How about ln x minus 3? Where is the asymptote for ln? And pay attention, that's x minus 3, like this. It's going to be a 3, x equals 3. That's exactly right, because normally the asymptote's at 0. When you do that, it shifts everything 3 units to the right, so that asymptote would be at 3. Good. Number 3, what's that gonna look like? 1/2 to the x power. Do you know? It's a decay, absolutely, it's a decay, but it's also an exponential, right? So it's going to look like this, right here, except it's going to go this way. So that's a decay. What's the domain and range? The picture I'm looking at is right here. This is y equals 1/2 to the x. It's a decay. What's the domain? All reals, right? And we express that in interval notation like this. That would be our domain. What's our range?
You know that in front of you?
0 up. That's exactly right. From 0 up. Now, the range for this one where we added 2, remember, and we said the asymptote would be up here? That range would be 2 up. But this one is 0 up. Good. We already got an asymptote. Our asymptote's right here at y equals 0. And we already said it was decay. All right, we got that. Oh, let's try 4. I think we've only done one of these, and that was on that other practice thing. So let's make sure we can do number 4. So the log is 0.012, and the other one is 0.456. And you're going to find, we'll just do one of them. We'll find the log base x of the cube root of 14. Or we can do the other one too if you want. Okay, who's got a plan? That's a radical. So we're going to make it a fractional exponent. Radicals don't jive with logarithms. So we're going to change that into 14 to the 1/3. And then what can I do with the 1/3? Move it to the front. So now I'll have 1/3 log base x of 14. Now, look at what you were given. You were given the log of 2 and the log of 7. Is there anything coincidental about that? Okay, so you have 1/3 the log of 7 times 2. Now these are multiplied. If I want to pull them apart so that I'll have individual logarithms like I do here, how will I pull them apart? There's my 1/3. And I'll have the log base x of 7 plus the log base x of 2. Exactly. Remember, if numbers have been multiplied, their logarithms are added, right? Okay, then I can just plug in my numbers. So I have 1/3 0.012 plus 0.456. I've got this backwards, but it doesn't matter. I'm adding them. So then I can just go to my calculator, add them up. divide by 3, and the answer is 0.156. Let's quickly look at the second part of that. Log base x of 8x squared. Now, I know there's a 2 there, but do not take that 2 out here, because that 2 only goes on the x. So can I, if I want to break this up, can I break it up as the log base x of 8 plus 2 log base x of x? Can I do that? Is that too much? Do you follow that? Pardon me? You don't follow it? Okay. Now, what do I do with the 8? Remember, this is the given. They didn't give me 8. What am I going to have to do with that 8? 2 cubed. So as soon as I write it as 2 cubed, then I can take that 3 out in front. So I'll have 3 log base x of 2. What about this? That's 1. Good. I don't know who said that, but you're right on target. That's 1. So this is just plus 2. Because when these numbers match, the answer is 1. The log base 7 of 7 is 1. The log base 8 of 8 is 1. So then you can go to your calculator and it's easy. So this, remember, is 0.012. So it looks like 2.036 is the answer to the question. Now, I picked a few there that I thought we should talk about. Look it over. Nothing else here we need to talk about? All right, let's go back to the sheet on top. It says Precal Chapter 3 review sheet. We're now on the Precal review sheet. We're looking at Chapter 3 review sheet. In my packet, it's the one on the very top. Anybody have a question about this? The circled ones are the calculator problems. Everything else you should be able to do without a calculator. So think about, if it's not circled, think about, could you do that without a calculator? Which one?
8.
8.
Like the very last one.
H. The relationship between intensity of light and Fall Creek is given by this equation. Okay, so we are given an equation. We're on problem number 8 on the sheet called Chapter 3 review sheet. And problem number 8, formula is given. And it says, and it tells you what everything is. So the intensity of light at a depth of x feet. What is the intensity at a depth of 40 feet? Okay, what am I going to do? Plug in 40 for x. So I have the log of this equals negative 0.0125 times 40. I'm just going to plug in 40. And I'll go ahead and do that on my calculator. So negative 0.0125 times 40. I got negative 0.5. So I have this equation now. I have that equation to solve. It's a, oh, go ahead.
I was gonna say the log is the basic tax rate,
Ex-
put that on the other side. Negative 0.0125.
Beautiful, beautiful. When you have the logarithm equal to a number, you're gonna loop-de-loop. We didn't have a base, but he remembers that log always means 10. If there's not another number there, it's 10. So he says 10 to the negative 0.5 is I over 12. So I'll type 10 raised to the negative 0.5 power, and then multiply that by 12. And the answer is 3.79 lumens. I'm not sure how I'm supposed to be rounding, so I'll just say 3.79 lumens, because that's the unit that's given in the problem. Okay, Grace, does that make sense? Is your hand up?
You do 1A.
On the same sheet, 1A? Yep, 1A. Write the exponential function containing 0, 2, and negative 1, 3. Well, the first thing you have to remember is that exponential functions are a times b to the x. So really you're in trouble if you don't remember what you're heading toward. This is the kind of equation I want right here. And I know that it contains the points 0, 2, and negative 1, 3. Okay, so what do? Yeah, so it depends. If you remember that this number is the initial value, then you automatically know A is going to be 2, because your initial value is always the y-intercept, 0, comma. If you don't remember that, you're going to plug that point in for x and y. You don't have to do this, but if you forget, obviously A is going to work out to be 2, because this is 1, so A is 2. So you now know you have 2b to the x. Your equation is 2b to the x. So then we'll plug in our other point. So 3 equals 2b to the negative first. So we'll divide by 2. Always, always, always get rid of this coefficient. So 3 halves equals b to the negative first. So you can either look at that and say, well, if 3 halves is b to the negative first, then b must be 2/3. But if that doesn't make sense to you, 3 halves equals 1 over b, right? That's 1 over b. Cross multiply, so 3b equals 2, 3b equals 2, and b equals 2/3. Now, hugely common mistake that's made here is you forget that's not the answer. The answer is the equation. So 2 times 2/3 to the x. That is your equation. Never multiply these. No matter what they look like, don't multiply them. All right, who else? Well, we got a big test, guys, and remember, tests count a lot in your grade. So right now, everybody's got like these A pluses because all we have are homework grades. When that test grade goes in, well, let's just make it a good test grade so nothing bad happens. Who had a question? Somebody's gonna say something over there.
Can you do 1B?
Oh, yeah, I'm sorry. 1B, yep. Now we're writing the logistic function. So just like over here, we have to remember what it is we're shooting for. And we are shooting for y equals a over 1 plus b c dx. That is the format we're using to set up our logistic functions. Now, from all the given that they've given me, they gave me a lot of information there. Which piece do I start with? I know A is 12, so I start with the limit to growth. This number is the limit to growth, so I don't need to do anything except plug that in. I'm just going to start by plugging in my limit to growth. That, yeah. Just like you have your exponential. Yeah. Okay, so what's next now? What piece of information am I going to use next? Initial value. And I'm going to remember that an initial value of 10 means this point. So 10 goes in for y. Declan, do you have a question?
No, good.
Okay. 10 goes in for y and 0 goes in for x. Rory, are you multitasking or are you hanging in there with this? Okay. I need you paying attention here. So 10, oh, wait a minute. What's c to the 0? 1. So that is like it's really not even there. So 10 plus 10b equals 12. And 10b equals 2, so my b must be 1/5 if I divide by 10. Now, I have an equation that looks like this now. Y equals 12 over 1 plus 1/5 c to the x. So now the only thing left is that point, 2, 2. So let's plug that in and see what happens. So we'll cross multiply. Subtract 2. This one's on a no calculator, so we're going to have to be able to do this now. So 2/5 c squared equals 10. What do I do now? By 5/2, exactly. Which is the same as dividing by 2/5 if it's easier for you to think about it like that. So c squared equals 25, 50 over 2. And then obviously c is 5. So my final answer looks like this. Y equals 12 over 1 plus 1/5 times 5 to the x. Do not cancel these. You can't combine those ever, ever, ever. They stay as two separate numbers. Okay? Grace, that answer your question?
Yes, thank you.
Uh-huh. Whoa, what's C? Write the equation of the logarithmic function that has been shifted 4 units left and 3 units up from y equals log x. So your BFF is y equals log x. What would you have to do to the equation to shift it 4 units left and 3 units up? What would that look like? Y equals what?
+4.
Log parentheses x plus 4. Won't that take it 4 units to the left? And then up 3. Put a +3 on the end of it like that. Don't worry too much. In number 6, I've got you analyzing the functions. Don't worry too much. You got to know domain, range, asymptotes for sure. But don't worry too much about the rest of those function analysis things. All right. Let's turn the page and look at Precal A, Review 2. Precal A, Review 2. Take a look at that and see if there are any problems. Once again, the circled ones are the calculator ones. Anybody see anything there that looks like it might challenge you? I know it's the period after lunch. And I know this may not be your favorite place to be, but what this is telling me is I don't need this review day in the future. So next time we won't review. I mean, if it's not necessary, I need your participation. I need you to look at the problem and tell me, oh gosh, I don't think I could do that. Because we can do
You start with number 1.
Number 1, log base 6 of 13. There's a short way and a long way to do this problem. What's the short way? This is review number 2 for chapter 3. It's a change of base. Says log 13 divided by log 6. That's it. That's all there is to it. We go to our calculator, we type that in, and we get a decimal. That's the easy way to do it. It's always the log of this over the log of this. If you have to evaluate, actually find a value for a logarithm that isn't base 10 or base e, this is how you're going to do it. All right, anybody else?
Can you do number 8?
I heard somebody say 3 and then I'll do 8. Yep. 3 and 8 are both no calculator problems. This one is a calculator because you're going to type that in. But 3 says, what's the log base 7 of the 4 through the 49? This looks familiar to me, but might be, who knows. I need to figure out what this equals. So the first thing I notice is I have a radical. That is not a good thing, okay? So I'm going to change that 4th root into what? Yep, the 1/4 exponent. That's exactly right. Now I've got a couple of choices here. I can either pull that exponent out in front, or I can leave it there, recognizing that 49 is 7 squared. So if I choose just to leave it there, then I'm going to have a double exponent because 49 is 7 squared. And I chose to do that because there's a 7 there. So I kind of clued me in. So I have 7 squared to the 1/4. I multiply those. So I have the log base 7 of 7 to the 1/2. Multiplying those. And of course the log base 7 of 7 to the 1/2 is just 1/2. Okay? pulled it out in front, you'd have 1/4 log base 7 of 49, which is 1/4 log base 7 of 7 squared. Well, that's just 2, so 1/4 times 2 is a half, so you could do it that way too. Now, 8 is an equation. I hope it doesn't happen, but I can almost guarantee somebody is going to say 6x minus 1 plus 3 equals 9. And you cannot do that. You cannot just disregard the logarithms. Except in one special circumstance. If you want to drop the logs, you have to have 1 log equal to 1 log. Can I get that in this problem? Can I get 1 logarithm over here? Yep. What will I do with this stuff? I need to do something with the 6x minus 1 and the 3. What will I do with those? Multiply them. So that's going to be 18x minus 3, is that right? Now I can say 18x minus 3 equals 9. Because if you have log equals log, you can drop them out. That is the only time you can do it. ln is log. ln is log base c. Yeah. There's no difference there. It's just a different base. It's like having a base 7 versus a base 6. The properties are the same. So 18x equals 12, and x equals 2/3.
Okay, is there questions real quick?
Is it an absolute emergency?
I mean, I kind of,
Go ahead, sign out. Put the date and sign out. Okay, who else? Anybody else on this particular sheet? This might be our last one, actually. Oh, no, we have one more. 9. Write the equation of the exponential function. Huh?
Yeah.
Okay. We did one like this a second ago, but that's okay. We can do another one. I'm pretty darn sure it's been on every review sheet. I'm pretty sure it's going to be a test question. All right, so we got to figure out what A and B are. So what do? So we can either plug in the point 0, 2. You're going to start with that point, okay? You either plug it in, or you can recognize that the initial value is just going to be the y-intercept. So if you plug in 0 for x and 2 for y, you will get that A is 2. That happens automatically, so I'm just going to put it in. Now I'm going to put in 6 equals 2b to the negative first. So I'm putting in my other point, 6 for y and negative 1 for x. So 3 equals b to the negative first. Now, some of you are going to be intuitive about that, and you're going to know what that is. The rest of you are going to say 3 equals 1 over b, because that's what b to the negative first is. So 3b equals 1, and b equals 1/3. Then you'll remember to write your equation, y equals 2 times 1/3 to the x. Okay, comfortable? Okay. Anything else on this page? Anything at all? We don't have our books out, so we're not sure what those are. You might want to look at those on your own. But anything else? Yeah. 10. A population increases and by what percent does it increase each hour? So basically what we're looking for is R. And which formula am I going to use?
A equals PE and number 2.
Yep, it's going to be a PERT problem, because it's a biology problem. We have a population going from 1, 2, 3, 4 to 9, 8, 7, 6, 5. And it's doing it in 77.6 hours. So the first thing you're going to do is divide 98765 by 1, 2, 3, 4. ln each side. I heard somebody say that. We're going to take the logarithm of both sides and we'll use natural logarithms. That will make this go away. So won't our answer ultimately, that ln, that big fraction, equals 77.6r? So won't we just take the natural logarithm of that fraction and divide it by 77.6? So our answer will be ln 98765 divided by 1, 2, 3, 4. I got 0.0565, or about 5.65%. 5.65%. Does that make sense?
Have a good one.
Anybody else see something on here? Remember, these are all potential test questions. Okay, well, we have one more to look at, and that's the one that's called Practice Test 2. And it looks like all the same kinds of problems, but look at it and see if there's anything you're wondering about. Practice Test 2. All right, so here's what I would suggest that you do. I would suggest that between now and, what is it, Tuesday, that you spend some time with these review sheets. And I've given you the answers so you can work them. And let's see. So it's Tuesday, day 1. So we have office hours on Tuesday morning, so you're free to come in with a problem attempted. Okay, don't come in and say, I don't know how to do anything. No. Come in and say, I don't know how to do problem 3. I don't know how to do this problem. Okay? So put some time and energy into it. I'm sure you're all going to do just fine. You guys, you will need to print. I don't have it up yet. I haven't made it yet. But I will create an answer sheet, and you'll have to print that, okay? So make sure that you print the answer sheet before Tuesday. All right? And it'll be in Schoology whenever I get it time to put together. Okay? All right, I'll see you guys. Do some reviewing on your own. Bye. Okay. I gotta make our seating chart. So always put you in charge today. And Grace, I'm putting you in charge. Please do not wipe off the desks until 49. Do not wipe off the desk until 49. I need to make our seating chart. Sorry.
They have two of Avon starting markets. Had nothing to do with St. Valentine.
You talking about CYO basketball?
Yo, what did you just say?
Avon wide receiver. They're right by us. They play no, when we were in fifth grade, they were really
Okay, you can go ahead and wipe off your desk, guys.